Last time we saw the different applications of NPN and PNP transistor and how to turn them on. Now we'll see how we can use an NPN transistor in an overvoltage protection circuit. So let's start. Overvoltage protection shuts down the power supply or clamps the output voltage when the voltage rises above maximum permissible voltage value. An overvoltage condition might occur in the power supply due to fault inside the power supply or from external causes such as surge in power supply lines. In this protection, we have to set a threshold voltage above which the control circuit shuts down the power supply or divert the extra voltage to the other part of the circuit. And we can use BJT to protect any circuit from overvoltage. This is one of the most important applications where BJTs are widely used. Let's take an example where we have some load like CCR with LEDs or an embedded system. Every IC or power supply has some input voltage range in which it works without damaging. Let's take an example of a CCR. I don't know, I just love lighting loads. Those are just very easy to explain. We can use both NPN and PNP transistors for overvoltage protection. In this video, we'll see NPN transistor which can be used for overvoltage protection. Let's consider this CCR as a load box. We connect a BJT in series with the load and a supply so that it cuts off the supply when the voltage exceeds. Basically, it acts as a switch. We are placing this transistor after the load, which is known as a low side switch. If you want to know more about low side switches and high side switches, please check out this video. We'll name this transistor as Q2. We'll add one resistor from the supply to the base of the BJT. This resistor will keep the BJT on all the time, so the circuit turns on whenever supply is given. Now, when the voltage exceeds, this transistor has to shut down. So to turn this transistor off, we need to add one more BJT which will be connected like this in the circuit, so that when it turns on, it will pull the base of the Q2 to ground to turn it off. Now Q1 is our smart device. It should know when to turn on and when to keep itself off. The base of the transistor should be at least 0.7 volts to turn on an NPN transistor. To do so, we have a very easy solution. We can just use a voltage divider and design it such a way that when the certain voltage limit crosses, this divider will give 0.7 volts to the BJT and it will turn on, which will pull the base of the Q2 to 0, and Q2 will also turn off, which will cut off the circuit. Well, that's how the circuit will work. Let's take an example where the input voltage is 13 volts and we have designed this circuit in such a way that when the voltage goes beyond 18 volts, the overvoltage will get activated and the circuit will be cut off by this transistor. Main requirement for this circuit is that the current handling capacity of the Q2 should be higher than the current flowing through the circuit. Now we'll see the simulation of this circuit. The circuit is the same which we have discussed earlier. Both transistor Q1, Q2 and resistors are connected as per our design. Input voltage is 13 volts. And now if you see the simulation, .5 ampere current flows through the circuit without any disturbance, which is a normal operation. Now I am changing the input voltage from 13 volts to 19 volts. And the simulated result shows that the circuit is cut off by the Q2 and there is no flow of current in the socket. Well, that's how an NPN based overvoltage protection works. This circuit will work flawlessly up to 18 volts, and above that, the transistor Q2 will cut off the current gradually and fully up to 18.7 volts. Well, This is the voltage divider based protection. We can do the same with Zener diodes to add more stability to the circuit. So instead of R1, we will add a Zener diode which has Zener voltage of 18 volts, and we'll add one more current limiting resistor for the base of the transistor. Now if you simulate the circuit with 14 volts, it works fine. When I change the voltage to 19 volts, the circuit shuts down by this Q2 again, because at 18 volts, the Zener diode starts conducting, and after that, it goes to the Zener breakdown region. And current starts flowing through it, which will turn on Q1 and Q2 will be turned off. Well, that's how an overvoltage protection with NPN BJTs work. Next time we'll see the same protection using PNP transistors. Till then, stay tuned. I hope you got something from this. If you haven't, you can watch the video again. Still, if you don't, you can ask your doubts in the comment box below. Hit the like button if you like this video, subscribe to my channel, and finally, thanks for watching.